This video covers mapping objects on D3 map projections. The structure of this video is as follows. The goal: D3 pattern revisited, mapping GeoJSON objects the D3 way, mapping objects on D3 map projections, and the summary. Alright, let's get started. The goal. The goal of this video is to serve as an introduction to mapping objects onto a D3 map projection. In this video, we are going to cover how to think about mapping objects in D3 the D3 way. Using the SVG maps of Canada, Mexico, and the United States, we will map their capital cities by using a circle to represent where the capital cities are located. We will add mouse over and mouse out functionality to be able to access and display a data property that is bound to the SVG circle element. Finally, we will also cover how to make sure that as map projections change, the city locations projected on the map change as well. D3 pattern revisited. This is the D3 pattern we have seen many times before for binding data. First, we select the SVG container. Then we select all the element that we want to add. Then we do a data join. Then we choose the enter selection. Then we append the element that we want to add, which combines the enter selection with the update selection. Then we define some attributes that pertain to the SVG element we want to add. The data join is where the main magic happens. The reason we want to look at it today is to revisit what format the data set must be in when fed into the data operator. The data structure that has to get passed into the data operator is an array. The array can be filled with any type of data values. They can be numbers, objects, or functions that return other arrays of values. We can even specify key functions if we are doing the D3 general update pattern. Regardless of what data structures we are passing in, they must be in an array. A few videos ago, we used the data set on the screen. It is an array of JSON objects. Each JSON object represents a city. And because JSON objects can have any type of data structure in their values of the key value pairs, we could have made the objects as complicated as we like. One type of complicated JSON object that we can add to arrays are the GeoJSON objects. Next, let's take a look at how we can incorporate GeoJSON objects into our D3 data operator worldview. Mapping GeoJSON objects the D3 way. The GeoJSON object always consists of a single object. This object represents either a geometry, a feature, or a collection of features. A collection of features has one or more features. A feature has one or more geometries. A geometry is where we find the point, line, and/or polygon. If we look at the basic GeoJSON geometry object, you can see that the coordinates key value pair value has an array of coordinates. This means that we can pass these coordinates to the D3 data operator. Then, each coordinate array of longitude and latitude would be bound to an object by the D3 data operator. We could then use the bound data in many different ways. This is a GeoJSON feature object. Notice that all of the three key value pairs do not have any arrays as values. This means that at this level, we cannot pass anything from this object to the D3 data operator to bind to other objects. This is a GeoJSON feature collection object. Notice that the features key value pair value is an array of GeoJSON feature object or objects. This means that we can pass an array of features to the D3 data operator. Once we have bound each GeoJSON feature to an object, we can then use the GeoPath SVG path generator to convert the GeoJSON object to SVG path mini language instructions. Let's take a look at an example. In the last two videos, we have been using a USA GeoJSON file from a GitHub repository that contains GeoJSON objects for different countries in the world. If we open up this GeoJSON object, we can see that it is a feature collection object. The feature's key value pair value has an array of GeoJSON feature objects. In this case, there is only one GeoJSON feature object. It is the GeoJSON feature object representing the geometry of the USA. In the last video, we added two more files, one for mex GeoJSON and one for can GeoJSON. As these two files came from the same GitHub repository, they are the same type of GeoJSON objects as the USA GeoJSON. So we have three different GeoJSON feature collection files, and each feature collection has only one feature. Because we downloaded them as three separate files and stored them as three separate files, in order to draw them, we had to make three different D3.json XHR type-specific AJAX calls to load each one. As you can imagine, this could potentially lead to errors. It would be prone to errors because we are running three different asynchronous calls to get data. If one stalls or takes longer than the other ones, then the visualization would look incomplete at best. If there is logic involved during the AJAX call that has effects in the program, it could just make the code break. To fix this, we can combine the files in a GeoJSON object-friendly way. We can have multiple features in the feature collection object. We still have the same GeoJSON feature data for Canada, Mexico, and the USA. It is just that it is now enclosed in one GeoJSON object. Furthermore, this means that as we now have an array of objects, we can use the D3 pattern to bind each feature object to a respective SVG object, which makes the code more readable and familiar. Also, it means that we only have to do one AJAX call. Ignoring the styling of the countries for a second, let's look at the combined D3.json XHR AJAX call. We combined the three GeoJSON object files into one that has the three features in one feature collection. So we load the combined file and then use the feature collection object. If we look at the highlighted row, we should remember that in a feature collection object, there are two key value pairs. One key is for the type of GeoJSON object and one key is for the features array. You can see that we are getting the features array from the data object. We then pass this array to the D3 data operator. Then we select the enter selection and append SVG paths. This means that each SVG path will have bound to it one of the GeoJSON feature objects, which means we will have three SVG paths where each one represents either Canada, Mexico, or the USA. Then, just like before, we use the GeoPath with our selected GeoProjection to convert the GeoJSON feature object into SVG path mini-language instructions. Because this is done the D3 way with the binding of the data and the creation of the SVG path elements, everything we have learned about D3 so far is applicable to interacting with the paths of these countries, which means we can use the bounded GeoJSON feature object to define the ID of the path. We can also use the bounded GeoJSON feature object to style the path fill. Let's take a quick look at the JavaScript console to look at the example. We are running this web page off of a Python simple HTTP server that is responding to the D3.json requests. The index.html file has all of the D3 code that is using the D3 pattern to create the SVG paths based on the GeoJSON feature collection data we load. The feature collection contains the three GeoJSON features, where each GeoJSON feature represents the GeoJSON object for one country. We load the map using the D3 GeoMercator projection. In the JavaScript console, let's select all of the path elements in the page. You can see that it returns an array of three elements. This is what we would expect given the three GeoJSON feature objects we bound to paths. Next, let's click into the first SVG path element to look at its data attribute. When we click into the data attribute of the first path, you can see the key value pairs from the GeoJSON feature object. We have keys for geometry, ID, type, and properties. Next, let's click into the geometry key value pair. Here you can see the type and coordinates keys as well as their respective values. So all in all, we see that we have the full GeoJSON feature object bound to the path element. All the fully encoded GeoJSON feature object data is now available to us. Next, let's close the first element and go into the third element. When we open the third SVG path element to look at its data attribute, you can also see that it has the same structure as the first one. which is great news because we are able to map GeoJSON objects the D3 way. And because these objects are bound to SVG paths, everything we have learned along the way for interacting, animating, and transitioning path objects based on bound data will hold true for the maps of these countries. As a show of what is now possible because of the binding of the data in this way, I've added transitions to the GeoPath projections dropdown. The animations give us a much better feel for how the geo projections differ from one another. Now that we are mapping GeoJSON objects the D3 way, let's next talk about how to map objects onto these maps with D3. We will focus on cities in this video as they are the most basic example. Mapping objects on D3 map projections. This is the D3 Geo equirectangular projection. We are using the D3 pattern to bind the GeoJSON feature objects to the paths. We have colored Canada red, Mexico green, and the USA blue. What we would like to do is to place each country's capital city in the right location on each country. Each JavaScript literal object is comprised of two key value pairs. The keys are name and coordinates. Note that only two keys were chosen for ease of exposition. You can make your objects as information-rich as you want. The name key's value is a string of the city name. The coordinates key's value is an array of the longitude and latitude of the city. The longitude comes first. Note that the numbers are currently strings in the array. This is to highlight that sometimes when you get JSON objects, you will have to do a string to number conversion. Let's look at the Mexico capital city object for a second. In order to place Mexico City on the map of Mexico, we are going to have to turn the longitude and latitude coordinates into SVG X and Y coordinates. So far, we have been passing GeoJSON objects to the GeoPath functionality, which then, in turn, return to us SVG path mini-language instructions, which means we could try to pass a GeoJSON single-point geometry object to the GeoPath function. The issue with this is that it would return SVG path mini-language instructions. What we really want to need are the SVG X and Y coordinates that correspond to the given longitude and latitude points. In this way, we can then create an SVG object with those X and Y points that would sit exactly where it needs to go on the SVG viewport given the geo projection we are using. In this case, since we are using the D3 Geo equirectangular projection, the SVG X and Y points would have to correspond to this projection. All D3 projections provide this functionality for us. Given a projection, if we pass in an array of longitude and latitude points, it will return Cartesian X and Y coordinates to us. The only time this does not work is if the longitude and latitude points are outside of the bounds of the projection, which can happen with projections like the D3 Geo Albers USA projection. In the JavaScript console, let's take our three city objects for Ottawa, Mexico City, and Washington, D.C. and run them through a few projections to see how the conversion functionality works. This webpage has the D3 library imported from the D3.js.org website. We are in the JavaScript console. First, we define the Canadian capital city of Ottawa. Next, we define the Mexican capital city of Mexico City. Next, we define the American capital city of Washington, D.C. Now that we have our capital cities, let's first run them through the default GeoPath projection, the D3 Geo Albers USA projection. We start with the American capital city of Washington, D.C. The USA capital dot coordinates gives us the longitude and latitude array. When we run it through the Albers USA projection, we get back SVG X and Y coordinates. Next, let's process the Canadian capital city of Ottawa. Canada capital dot coordinates gives us the longitude and latitude array. When we run it through the Albers USA projection, we get back SVG X and Y coordinates. Next, let's process the Mexican capital city of Mexico City. Mexico capital dot coordinates gives us the longitude and latitude array. When we run it through the Albers USA projection, we get back null. This is because the longitude and latitude for Mexico City are outside of the D3 Geo Albers USA projection. This is an example and a reminder of why it is important to think about what you are mapping and how it fits into the projection you have chosen for your project. Next, Let's do the same exercise, only this time with the Mercator projection. We start with the American capital city of Washington, D.C. When we run it through the Mercator projection, we get back SVG X and Y coordinates. You can see that these coordinates are different from the coordinates returned by the Albers USA projection. Then we run Ottawa through the Mercator projection. Then we run Mexico City through the Mercator projection. You can see that with all of these, a 2-element array is returned. If we wanted to get the X coordinate from one of these results, we would have to get the 0 indexed element. If we wanted to get the Y coordinate from one of these results, we would have to get the number 1 indexed element. Let's get the X coordinate from the Mexico City SVG X and Y coordinate array. Using the array functionality, we are able to get the X coordinate, which is the 0 indexed element. To get the Y coordinate, we would have to use the 1 to get the second element of the array. Let's go back to the notes to see what we can do with this. What we can do with these objects is to set up an array of capitals so that we can pass the city objects as members of an array to the D3 data operator. This will allow us to use the D3 pattern to create an SVG element for each capital city. Then, once we have created the SVG elements, we can convert the longitude and latitude to X and Y SVG coordinates in order to properly place each element accordingly. Using the array of capital city objects, we can pass it to the D3 data operator as shown. Then, using the projection type that we have chosen, we can get the X and Y coordinates out of the capital city object. We use the converted X coordinate as the CX of the circle. We use the converted Y coordinate as the CY of the circle. This allows us to place the circles in the right place on the map given any type of projection. Because we created the circles the D3 way, it means we can easily attach mouse over and mouse out event listeners to them. So regardless of where they are placed, we can create a tooltip to show up next to them. In this code, we select the circle and extract the city name from the object that was bound to the circle. Then, using the D3 event page X and D3 event page Y, we can place an HTML div on the page and give it the name of the city. Then, when we mouse out, we can hide the HTML div and it will disappear. This is the HTML div that we will use. The placement is based on the mouse over event. The mouse over event will use data bound to the SVG circle to update this HTML div in order to properly reflect the SVG circle we have moused over. The D3 event page X and page Y will move this HTML div element to be right next to the circle we have moused over. Lastly, it is important to take a look at the draw/redraw function. Every time the drop-down HTML select box is triggered, it will call this function with the new type of projection selected. First, we will define the new geopath variable with the new projection that was selected. Then, we will update the SVG path for each country using the new geopath that has the updated projection. We use a transition to help with object constancy, that is, so that we can follow the object through its transformation. Then we will update the placement of cities on the map projection. Using the circles that are already there, we extract the data bound to them and run them through the new projection. So we reconvert the attached object's longitude and latitude array into new SVG X and Y coordinates using the newly selected projection. We then use these SVG X and Y coordinates to reset the CX and CY of the circles. Overall, this data visualization is made up of these steps. Though it seems like a decent number, they all do a specific job and are easy to understand in parts. The source code included with this video will help break down all of the steps. Let's now take a look at how it works on the webpage. This webpage has the D3 library imported from the D3.js.org website. The D3 code has been written into an index.html file. We are running this page using Python simple HTTP server. On the loading of the webpage, you can see the circles for Washington, D.C. and the circle for Ottawa. Let's next switch the projection to the Mercator projection. After we zoom and pan, we can see the 3 yellow circles. Each circle represents the capital city of that country. We can see Ottawa, Washington, D.C., and Mexico City. Let's hover over each circle. As we hover over the circles, you can see the city name pop up. This means the event listeners are working and that we are using the data that was bound to each of the circles. Let's next switch the projection to the conformal projection. After we zoom and pan, we can see the 3 yellow circles. Because we put a transition on the circles as well, you can see that they follow the countries where they belong. With each new projection, the redraw function is translating the longitude and latitude points into new SVG X and Y coordinates. When we hover over the cities again, we can see that the event listeners still work. Let's now go through all of the projections quickly to see how the circles move with their respective countries. As we go through all of the projections, pay close attention to the switch from Mercator to orthographic projection. To me, it really gives a sense of the map being wrapped around a sphere. And with that, we have covered mapping objects on D3 map projections. We started out by revisiting the D3 pattern and making sure to understand that we can use the arrays and GeoJSON objects to put the D3 pattern to great use. We then covered a small example of aggregating GeoJSON feature objects into one GeoJSON feature collection object for ease of using the D3 data operator. Then we covered how geoprojections help to convert longitude and latitude coordinate pairs to SVG X and Y coordinate pairs. Lastly, we played around with transitions between D3 geoprojections to get a sense of how they work and to check to make sure that the redraw function was indeed converting longitude and latitude pairs to the right SVG X and Y coordinate pairs given the countries the circles represented. The summary. This video covered the goal of this video, D3 pattern revisited, mapping GeoJSON objects the D3 way, mapping objects on D3 map projections, and the summary.